we have other important things that we have to learn. How we are going to do the deletion of a vertex and how we are going to do a deletion of an edge. Okay, so that are the things that we are going to basically check here. So here if you see, if vi be a vertex in a graph, then the subgraph obtaining by deletion of this vertex vi, you can denote it as g minus vi, and it is the graph which is obtained by deleting the vertex vi and the edges incident on the vi. So if I wanted from this graph, I want to remove this vertex vi, so I have to remove that vertex also, and also the edges which is incident on that vertex also I have to remove. So that particular graph that we got after removing that vertex and the edges which is incident on that vertex, that such graph we can denote as g minus vi. So here if I am seeing, I am removing vi means I will remove that vertex vi and the edges incident on vi. That means this edge, this edge, this edge, this edge are the edges incident on here. So these four edges I will remove. So this is the new graph which I got, g minus vi. Okay, now deletion of an edge means let ei be an edge in the graph g. Then the subgraph which is obtained by the deletion of the edge ei is denoted as g minus ei, and it is a graph which is obtained by deleting the edge ei from the graph g. So from the graph g, deletion of edge does not imply deletion of its end vertex. That is important. So here I will just remove the edge only. I won't remove the end vertices here. Okay, that is one important point that you have to remember. While removing an edge, you will denote that graph by removing the edges g minus ei, and here we won't delete any end vertices and all. We just what we're going to do is that we are going to just we are deleting in such a way that only that edge is removed, not the end vertex. So this is one of the most important thing that you have to understand. We will remove only that edge here. If I want to remove ei, I will remove that ei only from here. Okay, fine. Now we have to understand about the fusion. So in the case of fusion, the pair of vertex u and v in the G is said to be fused. If the two vertices replaced by a single vertex and all the edges that is incident u are both are made inside. So means if I'm saying that fusion of a vertex means there would be two vertex. Let us see, the question is saying that from this graph G I want to fuse u and v. So I will make u and v as a symbol name, let's say w. I will replace the u and v with w, and whatever in edges are incident on u and v, I will make them incident on w. For example, if in this graph the question was, wait a minute, in this graph the question is that consider this graph G here, fuse the vertex C and D. So this is C, this is D. So I will make C and D to be one same vertex CD, and the vertexes, so edges which is incident, that is 2, 3, 4 are the edges, which is 6 are the edges. 6 is actually what? D itself. So that means there's a self loop of 6 because we are combining CD. So that means if C contains D itself, that means we are doing a self loop here for 6. So 2, 3, 4 is coming to here, and D has 5 and 7 coming incident on it. So that is 5 and 7 would also incident on the CD. And since C and D is connected with 6, and if I'm fusing C and D, that means a self loop would be created for the edge 6. And other edges which is incident on D, I will put it in, that is 7 and 5 are the edges which is incident on D. So I will connect it with this new edge CD, 7 and 5. And 3, 2, 4 are the edges which is coming from going to C. So that also we will put it in CD. So this is how we are going to represent the fusion. Thank you.